Hello, welcome to this lesson on integration. This is ITE 1812 Mathematics for IT. We will first look at the learning outcomes. By the end of this lesson, you should be able to define definite and indefinite integrals and compute indefinite integrals, as well as use definite integral to find the area covered by a function. Let's get to the introduction first. Integration, or finding the integral, is a fundamental and essential operation in calculus. In the previous lesson, we discussed about differentiation, which is also a fundamental and essential operation in calculus. So what is integration? We can identify integration as the process of differentiation in reverse. Let's see how we do that. Let's get to the basics. Given a function fx, we determine another function denoted by capital Fx such that the derivative of capital Fx is fx or simple fx. So symbolically, you can write that as d over dx fx is equal to fx. So what happens when you differentiate capital Fx, you get simple fx. On the other hand, if you take the opposite, if you integrate simple fx, you should get capital Fx. So this is the idea of reversing. We will take an example. Let's say we have a function capital Fx and the derivative of capital Fx is 4x cubed. So we are given the derivative and we are required to find fx. So what was fx? We can recognize 4x cubed as the derivative of x to the power 4. So if you recall the lesson on differentiation, you will remember that when you differentiate x to the power 4, you will get 4 times x to the power 3 or 4x cubed. So we might have, it might be the case that capital Fx was x to the power 4. However, we should note that even if we define fx as, that is capital Fx, to be x to the power 4 plus 7, which is a constant. Even if you differentiate this new function, which is x to the power 4 plus 7, you see that you will get the derivative as 4 times x cubed, because the derivative of the constant will be 0. You will also see that this would be true for any constant c. Thus, we can see that there are infinitely many possible answers to this question. That means finding the integral of 4x cubed would have indefinite possibilities or answers. So we call the set of all antiderivatives. Why do we call that antiderivatives? Because we are talking about the reverse. So antiderivatives of a function, the indefinite integral of the function. So this is the introduction for an indefinite integral, this example. We will now formally define indefinite integral. So we denote it as integral of fx dx. So you can notice the sign for integration or the integral. So this is read as the indefinite integral of fx with respect to x. And it stands for the set of all antiderivatives of f, which is the function of x. Thus, the integral of fx dx is a collection of functions, because there can be many constants associated. It is not a single function or a number. The function f that is being integrated is called the integrand, and the variable x is called the variable of integration. So when we integrate a function, we integrate that with respect to a certain variable, In this case, it is x. This is how we formally define the indefinite integral. We'll take an example. So we are required to determine these indefinite integrals. In other words, find the antiderivative of each integral. So first one, part A, you have integration of 8 dx. Find the integral of 8 with respect to x. So the solution, you will see that when you integrate that, you have to have 8x plus another constant c. And then in part B, you have to integrate 3 times x squared with respect to x. Integral of 3x squared dx. So how do you do that? So when you integrate 3x squared, you need to find the function when it is when the derivative of that function is taken, you have to arrive at this original function, which means you see that when you integrate 3x squared, it becomes x to the power 3. And you have to add the constant c, x cubed plus c. And what happens in part C, you have to integrate e to the power x with respect to x. And you remember from the differentiation lesson that when you integrate ex, the answer will be also ex. So when you integrate ex with respect to x, your answer will be ex plus a constant c. And part D, you have 1 over x dx. You need to integrate 1 over x with respect to x. So if you recall from the differentiation lesson that when you differentiate ln x, you will get 1 over x. So this is the reverse now. When you integrate or when you take the integral of 1 over x with respect to x, you will arrive at ln x, the natural logarithm, plus a constant. We always have to add the constant for indefinite integrals. So the constant of integration c reminds us that we can add any constant and get a different antiderivative. So as we defined it in the previous slide, we can have many number of possibilities for this solution in the case of indefinite integral. So now we introduce some basic rules of integration. So taking the results of example 19.1, what we just discussed, it suggests several useful rules for integration, which is summarized in this theorem, theorem 19.1 given here. So first one is very basic. It is the constant rule. When you integrate a constant with respect to a certain variable, in this case x, so you have integral of k, which is a constant, k dx, and you have to have k times x plus c. So you can even validate this when you try to differentiate kx plus c, you will see that you will get the constant k, because constant c will be gone because it's a differentiation of a constant. It will be 0. But when you differentiate k times x, you take k out of it, k to the front, and then when you differentiate x with respect to x, you will get 1. And the whole answer will be equal to k. Eventual answer will be equal to k. So that's the constant rule, and that's how you understand the behavior of the constant rule. And then we have power rule. So this is defined for n not equal to -1. So we will see what happens when n is equal to -1 in the later slide. But let's first define the power rule where n is not equal to -1, because if negative 1 and n is equal to negative 1, the whole thing would be completely different. So when you need to find the integral of x to the power n with respect to x, it will be coming in as 1 over n plus 1 times x to the power n plus 1 plus the constant c. But this is defined, as we said, for n not equal to negative 1. So let's see what happens when n is not equal to negative 1. So that is the natural logarithm rule. So when n is equal to negative 1, we see that it's 1 over x. So when you integrate 1 over x with respect to x, you see that it is the natural logarithm, which is ln x. Plus you have to add the constant, where x is greater than 0. And then, of course, the exponential rule with e ax. A is a constant, where a is not equal to 0. Because when a is equal to 0, it will be 1. So when you integrate e ax dx, it will be 1 over a times e ax plus the constant. So this is what we call the exponential rule in integration. So these are some of the basic rules that are useful when we do simple integration operations. So now we will see how these rules are used in examples. So we are given these examples, use the rules of integration to determine these indefinite integrals. So first we have x to the power 7. So we apply the power rule. So what happens? You need to have x to the power n plus 1. So n is 7 in this case. So what happens? You have to have, when you integrate, the answer will be x to the power 7 plus 1 over 7 plus 1. So that will plus the constant, of course, and that will give you x to the power 8 over 8 plus c. Second one is a similar one, x to the power 99 with respect to dx. You have to do x to the power 99 plus 1 over 99 plus 1 plus the constant. And that will give you x to the power 100 over 100 plus c. Third one is the square root of x. In other words, it is the x to the power half or 0.5. So when you integrate, you can use the same power rule. So it is x to the power half. And then you have to have x to the power half plus 1 over half plus 1 plus the constant. And eventually you will get 2 times x to the power 3 over 2 over 3. So that's simplified to the eventual answer plus the constant. You always have to add the constant when you do indefinite integrals. And then you have another example, that is 1 over x cubed. So in other words, it is x to the power negative 3. Apply the same power rule. You have to have x to the power negative 3 plus 1 over negative 3 plus 1. So eventually it becomes negative 1 over 2 times x squared plus c. And lastly, we have e to the power 4x. So this is using the exponential rule. So what you have to do, you have to have 1 over 4, because the constant is 4, times e to the power 4x, and add the constant, of course, for the indefinite integral. With that, we move on to some more properties of integration. So this is the second theorem that we are looking at. So when we have a constant factor that can be moved to the front of an indefinite integral. So for example, when you have integral of c times, where c is a constant, c times fx, a function of x, with respect to x, you can take c out of the integral. You can, in other words, you can take the constant out of the integral and then integrate the function only. That's the first property that we introduce. And then when you have an integral of a sum or a difference with two functions, you can write it as the difference or the sum of the integrals taken separately. So in symbolically, you can write that integral of fx plus or minus gx, you can write that as integral of fx dx plus or minus integral of gx dx. So this is straightforward. So first we have the constant factor. We can take that in front, and when you have a sum or difference, you can take the sum or the difference of the integrals. We go through one more example here. So we are required to determine these indefinite integrals, and we can assume that x is greater than 0. So first one is integral of 3 times x to the power 5 plus 7 times x to the power 2 plus 8. And we have to integrate that with respect to x. So when you have something like this, remember the rule for sum or a difference. So here in this case, we have the sum of 3 different functions, 2 functions and a constant in this case. So you can separate them out. Okay, so first you can separate, you can take the integral of 3 times x to the power 5, and then you can have 7 times x to the power 2 plus integral of 8 with respect to dx. So of course, for the first part, you can take the constant in front, that is 3, and then integrate x to the power 5. So when you integrate x to the power 5, you will have x to the power 6 over 6. And similarly, for the second part, you can take the constant in front, 7, and then integrate x to the power 2. So when you do that, the answer will become x to the power 3 over 3. And when you integrate the constant, you basically have to add the x. So it becomes 8x. And then you can simplify. Eventually, the answer will be 1 over 2 times x to the power 6, 7 over 3 times x to the power 3, plus 8x. And then you have to, very importantly, you have to add the constant, because this is an indefinite integral. So that's the example one, where you apply the both rules, constant rule as well as the sum of 2 integrals. Second example, part B, you have integral of 4 plus 3x plus 2 times x to the power 4 divided by x. So for this also you can do a simplification. So when you divide, because we are given that x is greater than 0, we can divide all the factors by x, or all the components by x, and you will get the integral of 4 over x plus 3 plus 2 times x to the power 3. And then what you do is you integrate them separately. If there is a constant in front, you can take it in front. So the first part, when you integrate, the answer would be 4 times ln x, the natural logarithm. Third part will become 3x, second part will become 3x, and the third part will become 1 over 2 times x to the power 4 plus the constant. So this is how you apply the simple rules of integration when you have combination of functions. So far we have been discussing about indefinite integrals. Now we move on to what we call the definite integrals. So let's consider a function y, which is fx, a function of x. The integral of y between a and b. A and b are 2 numbers. Okay, so between these values, or in this range, we can define the definite integral. So when you do that, you see that you indicate at the end of the 2 ends of the integration symbol, you indicate the 2 values. So between A and B, you write at the bottom part, you write A, and the top part, you write B. So from A to B, fx dx. So this is defining a definite integral. So you can write that as, so when you integrate the fx, simple fx, let's say you arrive at capital Fx, and you can write that as capital Fx, box parenthesis, and B and A. So because you need to calculate the value of this integral between two values or in a range of values. So how do you do that? You take FB, that is substitute B in F, which is a function of X, and then minus FA, substitute A in the function of F. So when you do that, this is called the definite integral of the single valued and continuous function y equals simple fx between A and B. So A and B are two values. This also gives the area under the curve between A and B. So how do we get this area under the curve? When you plot the graph for fx, when you have the graph for fx, you have a graphical representation in this slide. So definite integral can be illustrated as in this diagram or the graph given in this slide. So you have x-axis and y-axis and the function fx and the values of x, a and b. So when you integrate this function between two values within a range, when that is what you do in definite integral, you will get the area under the curve of fx. So what you see in blue color in the graph is the area under the curve, and that's the value when you do, that's the value you get when you perform integration in that range for fx. So that's how you define the definite integral. We'll take a look at an example. So you have to evaluate the integral of, this is a definite integral because you see the range. You'll see the two values, 0 to 1 of x squared with respect to dx, with respect to x. So how do you do this? You first have to integrate the given function, which is x squared, and you see that it is x cubed divided by 3. Okay, so you apply the power rule in this case, and you integrate the given function. So after you do the integration, you have to apply these values in the function. So what do you apply first? Number 1 or the value 1, when you apply that in the function or the answer that you get for the integration, that is when you substitute 1 in x cubed over 3, you will get 1 over 3. And when you substitute 0, you will get 0. So eventually you have to do the subtraction from 1 over 3 subtract 0. And the answer would be 1 over 3. So you will see that, you will notice that the constant is no longer here, because you have even if you had the constant, when you do the subtraction, the constant will be gone, because you are calculating this value for a range. And you are taking the difference, or you are performing a subtraction. So at the two instances, even if you had the constant will be cancelled out. So we don't have to put the constant in the case of definite integrals. So you please note that important point. So when you do indefinite integrals, you always have to mention the constant. But in definite integrals, you don't have to. Because when you do the subtraction, the constant will be cancelled out, because the constant will be same for the both instances. With that, we come into the end of the lesson. So we discussed about an important operation in calculus, which is integration. Thank you.